Find the LCM of 52, 117, 121, and 132. Okay, and finding the LCM of these numbers, let us find out their prime factorization. So we start with 52. Draw a line by the side of the number and another one below the number. Let's start with the lowest first prime number, 2. Okay, you start with a prime number that can divide the number without a remainder. So 2 is the lowest and can divide 52 without a remainder. So 2 in 5, you have 2. Then remaining 1, you carry the 1 to the 2 becomes 12. So 2 in 12 gives you 6. 2 can still divide 26. So 2 divide 2, that's a 1. 2 divide 6 gives you 3. Okay, 2 can no longer divide 13 without a remainder. Neither the next prime number, which is 3, cannot divide 13. So you keep on moving on until we get to 13. 13 is the only number that can divide 13 without a remainder. So 13 divided 13 is 1. So the prime factorization for 52 is 2 times 2 times 13. Okay, so let's find out the prime factorization for 117. 117, you draw a line, then you draw another one at the bottom. Which number can divide? 2 cannot, because there's going to be a remainder. So we go with 3. 3 can divide this number without a remainder. 3 in 11, that's 3. Remainder, that's 3 divided 9. Remainder 2. 3 in 27, you get 9. Okay, then 3 can still divide. 3 in 3, 1. 3 in 9, 3. The only number that can divide 13 without the remainder is 13. Okay, that's the only prime number that can divide it. So the prime factorization for 117 is 3 times 3 times 13. Okay, let's go to the next number, 121. Okay, which number can divide? 2 cannot go without a remainder. 3 cannot. 5 cannot. 7 cannot. 11, yeah, 11 can divide 121. So 11 in 12, 1. Remainder 1, you take the 1 to the 1, becomes 11. 11 in 11 is 1. Okay, then 11 divide 11 gives you 1. So the prime factorization for 121 is 11 times 11. Okay, let's find the prime factorization for the last number, which is 132. Okay, you start thinking about which prime number can divide 132 without remainder. 2 can divide. 2 in 13, you have 6. Remainder 1, you take the 1 to the 2, becomes 12. 2 and 12, you get 6. Then 2 can still divide this number 66. 2 and 6, 3. 2 and 6, 3. 2 can no longer divide this number, so we move on to 3. 3 can divide 33. 3 and 3, you get 1. 3 and 3, you get 1. So the only prime number that can divide 11 we know is 11. So 11 in 11, that's 1. So the prime factorization for 132 is 2 times 2 times 3 times 11. Okay, so now with this we can find out the prime factorization, the LCM. We can find out the LCM. Okay, let's find out. 2 is appearing 2 times here, and it's also appearing 2 times in the factor that gives us 132. Okay, so that's the highest. In fact, that's the only times. So that's the highest time. So we represent that 2 times 2. We go to the next factor. We have 3. We have 3 multiples of 3 2 times here and just 1 time here. So we take the highest multiple, which is 2, 3 appearing 2 times. That's 3 times 3. Okay, then we go to the next factor, 11. 11 is appearing in the multiples of 2 here and here, so we take the highest, which is 11 times 11. Then we go to the last factor, 13. 13 is appearing just 1 and just 1, so we just pick the highest, which is 1 and only. Okay, now we punch in the calculator. Let's punch in the calculator to get the total product. Okay, 2 times 2, 4. 4 times 3, 12. 12 times 3, that's 36. 36 times 11, that's 396. 396 times 11, that's 4356. 4356 times 13 gives you 56,628. That is 56,628. Thank you for watching, and God bless.